In this lecture at Medical Sciences, we want to look at how can we prepare weak solutions from strong solutions. In case you are in the laboratory or in the pharmacy and you're given a strong solution, to prepare a weak solution by diluting. So we want to look at how do we dilute strong solutions or stock solutions to come up with what we need to use for analytical tests. So, and in this dilution of solutions, or what we can call preparation of weak solutions, we normally use the formula which is called RV over O equaling to X. This is the formula which we use, whereby R stands for the required concentration. This is the required concentration. And then V stands for the volume, the required volume, the volume required. Then O stands for the original concentration. This one stands for the original concentration. Then X stands for the volume of concentrated solution to be pipetted. So this is how I can describe these letters using RV over O, whereby we have seen R stands for required concentration, V stands for required volume, the volume you want to prepare in the lab for use. Then O is the stock solution or the original concentration which you want to dilute to form a weak solution. Then X is the volume of the strong or of the origin, which how much of the original you need to pipette, then you top up with either distilled water to make the required volume. So this is the formula we are going to use to calculate these different examples, 4 examples we are going to see. So example number 1 is we are required to prepare 500 ml of 0.25 molar solution from 0.5 molar sodium hydroxide. So we shall begin this calculation by saying X is equal to RV over O. Then you define what R means, what X means, what V means, and what O means, the way we have done it here. And after defining each letter, we are going to say that according to this calculation, R is equal to the required concentration is 0.25. So you identify what you have, molar. Then the required volume is 500 ml. And the original concentration is 0.5 molar. So since we have this, from RV over O equaling to X, we're going to see that X we substitute. Where there is R, we put 0.25. Where there is volume, we put 500 ml. And where there is O, we put 0.5 molar. And we are going to get 0.25. And always maintain units times the volume, which is 500 ml. You divide by 0.5 molar. And the molar is going to go with molar. And by 0.251, this one is 2. And by 2,1, by 2, this is 25. So it becomes 250. Therefore, X, the volume of the origin, which we shall need to pipette, is 250 ml. So what we are going to do, we're going to obtain our measuring cylinder, and we measure 250 ml of 0.5 molar sodium hydroxide. And after pipetting these. So we are going to pipette or to pipette 250 mils, but since this one is the big thing, we are going to measure. We measure 250 mils of 0.5 molar, which is the original sodium hydroxide. And after putting them into the measuring cylinder, we top up. We top up to 500 mils mark. Then after this, we mix well and transfer to the storage bottle. We transfer to the storage bottle. Then lastly, you label. And on labeling, you have to mention different requirements on the label, whereby you are going to put the initials of the person who has prepared, the concentration, that is 0.2 molar. Then you tell us even the storage temperature, the storage conditions. You tell us the manufacture date and the expiry date. Those ones must be put very well on the label. So this is example number 1 we can see. Then example number 2, we are required to calculate the volume. We are not required to prepare. So this is when they ask you to describe how to prepare. So at the end, after getting the volume to be pipetted, you go ahead and describe. But this one, they want you to calculate only. And according to this question, the volume I'm seeing is we need to prepare 1 liter. We are seeing the required concentration is 0.5% sodium hydroxide, and then the original concentration is 9% sodium hydroxide. X, we don't have it, which is what we are going to look for. So from RV over O equaling to X, we already know that R is 0.5, always maintain unit, percent, times the volume, which is 1 liter, you divide by 9%. Percent will go with the percent, and when you get 0.5 divided by 9, you will be able to get 0.56 liters. So liter will remain. So X is going to be equivalent to 0.56 liters. If you want, you can convert liters to mils, but if it is not so, you can even end from here. And we conclude by saying the volume of 9% sodium hydroxide required is 0.56 liters. And we stop there. So this is how we can calculate this. And because they are saying you calculate, you don't go further to describe. If they ask you to describe, then you increase the description. If they ask you to calculate, then you stop it from there. Hope you are following me. Then from here, we are going to example number 3. And under example number 3, the question is saying, you describe how to prepare 100 mils of 55 milligrams per deciliter protein standard from 3.5 grams per liter albumin. So in this calculation, we are seeing the required volume is 100 mils. The required concentration is 55 milligrams per deciliter, and we are using the original concentration of 3.5 grams per liter. So after seeing this, I'm seeing that the units are not the same. And before you apply anything in the formula, always make sure that the units are the same. And since here the units are not the same, we are going to convert grams per liter to milligrams per deciliter. So we are going to convert 3.5 grams per liter to milligrams per deciliter. And we know that 1 gram is equivalent to 1,000 milligrams. So what about 3.5 grams will be equivalent? We cross multiply, whereby it is going to be 3.5 times 1,000 milligrams. Then you divide by 1 gram. Gram goes with gram, and we are going to end up getting 3,500 milligrams. This one is milligrams. So we have got milligrams. Then another thing, we need to convert a liter into deciliter. And we know that 1 liter is equivalent to 10 deciliters. So after doing this, we are going to end up saying that 3.5 grams per 1 liter is the same as, where there is a 3.5, we put 3,500 milligrams, and where there is 1 liter, we put 10 deciliters. We substitute, because we have seen 1 liter is equivalent to 10 deciliters. And 3.5 grams per liter means 3.5 grams you divide by a liter. So which is 3,500 milligrams, you divide by 10 deciliter, and 1 0 goes with 1 0, we remain with 350 milligrams per deciliter. That is, so 3.5 grams per liter is the same as 350 milligrams per deciliter. I told you the units should be the same. And what we are labeling to is to make sure the units, all of them, are in milligrams per deciliter. If you want, you can also convert milligrams per deciliter to grams per liter. So any other way works. The major thing is making sure the units are the same. After getting the units are the same from X equaling to RV over O, already we have, this is going to be our O. Our original concentration is 350 milligrams per deciliter. Our R, that is required volume, is 55 milligrams per deciliter. Then the required volume is 100 mils. Then we divide by the original concentration, which is 350 milligrams per deciliter. And since the units are the same, now they cancel out. The milligrams per deciliter cancels out. We remain with 5,500 mils divided by 350, and the end result, this 0 goes with this 0, and the end result, or the answer, is going to be 15.7 mils. That is the answer, 15.7. So X is 15.7 mils. And remember, the question is saying describe. So after calculating the amount of standard, albumin standard, 3.5 grams per liter, which is 350 milligrams per deciliter. So we are going to measure or pipette. We are going to measure, or we pipette, shall pipette 15.7 mils of 3.5 grams per liter albumin standard. After pipetting these meals, we are going to top up with the distilled water. So we pipette and we put it in a measuring cylinder. Then we are going to top up with the distilled water up to 100 mils mark. Then after doing that, we mix well. After mixing well, we transfer to the storage bottle. And after transferring in the storage bottle, we label. We transfer to the storage bottle and label. And the label, I told you, you must put there the initials of the person who has prepared, date of preparation, the concentration you have prepared, the use, expiry date, and the storage condition. All of those ones must be written clearly. So that is what we can give you on this number. So always identify which one is the original concentration we are supposed to dilute and which one is the required concentration, and also the volume. In case the volume is not given, you can suggest yours in the answer. And always make sure that the units, before applying in RV over O, units must be in the same. If they are not the same, then you have to convert the way we have seen here. We first converted. Then the last example we are having here is you're required to calculate the volume of stock solution of 5% albumin needed to prepare a protein standard of 50 milligrams per deciliter. So according to this calculation and according to interpretation, they have given me the original is, but they have given me original, they have given me the required, but they have not specified the amount we are supposed to prepare. That is the required volume. So we have required concentration as 50 milligrams per deciliter. The original concentration is 5%. And what does the 5% mean? 5% means 5 grams dissolved in 100 mils of distilled water. That is what it means. Percent means grams in 100 mils, whereby 100 mils is the same as deciliter, because 1 deciliter is equivalent to 100 mils. So we can end up saying that 5% means 5 grams per deciliter. That is what it means. And imagine this is in grams per deciliter, this is in milligrams per deciliter. So what we are going to do is to convert 5 grams per deciliter to milligrams per deciliter. So we need to convert grams to milligrams so that units are the same. And we are going to see that 1 gram is equivalent to 1,000 milligrams. What about 5 grams? You cross multiply, that is 5 times 1,000, we divide by 1, and we get our 5,000 milligrams. Deciliter remains the same, so finally we are going to see that 5 grams per deciliter is the same as 5,000 milligrams per deciliter. So this is the standard. Then the required volume is not given in this question. So when it is not given, we can suppose that if here we suppose according to my laboratory where I work in, I want to prepare maybe 2 liters. Suppose I want to prepare 2 liters. So this is, it is not in the question, but you cannot calculate without knowing the volume you want. So you as a health worker, you decide, since the question is not demanding or it is not giving you what they want, so you suggest. That's why I'm supposing that for me, according to what I'm producing, what I'm preparing here, I only need 2 liters according to my workload in the lab. I only need 2 liters. They can move me for a good time. So suppose the volume is 2 liters. Even you can suppose 1 liter, you can suppose 500 mils, depending on what your lab can accommodate or your pharmacy. So after doing this, now we are going to say from RV over O, from X equaling to RV over O. We have seen that R is, or that is the required volume, required concentration, which is 50 milligrams per deciliter times required volume, which we have suggested 2 liters. For you can suggest another one, then divide by the original, which is the 5,000 milligrams per deciliter. Milligrams per deciliter goes with milligrams per deciliter. Then we are going to see this 0 can move with this, and by 2, 1 here, by 2, 250. So after getting this 250, here I have by 5, 1, and by 5, or I can, let me do it in this format, whereby I can first multiply 50 times 2. 50 times 2, that is 100 liter, divide by 5,000. And these 2 zeros go with these 2 zeros. I remain with 1 divided by 50 liters. If you can put it on a calculator, you can easily get the real volume in decimals, but we can also, since for me, I don't have here my calculator, I can easily leave it at this. So this is the amount or the volume of the stock solution, 5%. Please note, I have said you note NB that any number, suppose you are told that you are given a number in percentage. For example, they tell you 3%. Standard. 3% means you are getting 3 grams of the solute dissolved in 100 mils of the solvent. And 100 mils is equivalent to 1 deciliter. So we can end up saying it is 3 grams per 100 mils or 3 grams per deciliter, because we know 1 deciliter is the same as 100 mils. So you should know how to interpret in case you are given a percentage and you need to convert. And here we are being given that this one is the same as 0.02 liters. If you want, you can even convert it in microliters or in mils, whatever you want. So the final volume of the stock we needed, this is X. So it will be 0.02 liters of 5% albumin. This is the final answer. So hope you have enjoyed this session, whereby you have seen how we can dilute stronger solutions to prepare weak solutions for use during testings. So I'm ending up by giving you the exercise, whereby this exercise you can do it and you give me the answer under the comment section, whereby I require you to do this. I want you to, the question is saying what volume is needed to make 500 mils? What volume is needed? Meaning here there is no description. We are going to only to calculate. They are not asking you to describe or to prepare. What volume is needed to make 500 mils of 0.1 molar buffer from 2 molar twist buffer. So you have to identify the required volume, the original concentration, and the required concentration. Please, after calculating, write it under the comment section, in the comment section below, so that we can see the right answer. Thank you so much for learning with us. May the good Lord continue to bless you.